about defining what a solution is, right? Before discussing about a solution, I would like to bring you back to the very first chapter that we discussed when we defined matter. We said that matter can be a pure substance or a mixture, right? Do you notice the difference between a pure substance and a mixture? What's a pure substance and a mixture? How do you define that?
Pure substance is just one atom, like it's purely just that atom, to where a mixture is like a mixture of atoms. Like chemical mixture.
Okay. Can you give me an example of a pure substance? Okay, sodium is a pure substance, right? Okay, what else? How about water? Is water a pure substance?
No. It's a mixture.
You forgot things so quick. Yes, water is a pure substance. What is a pure substance? What's the definitions of pure substance? I'm asking you.
Pure substance are those substances that can be chemically changed.
Okay, let me make correction a little bit. You're right, but let me just modify your statement. A pure substance is a substance that has its own chemical and physical property, its own unique physical and chemical property. What it means is, for example, if we define water as a pure substance, where it comes from, regardless of where it comes from, we have the boiling point of water, the melting point of water is unique, right? If the boiling point of water is 100 degrees centigrade, if you have a substance which boils at 100 degrees centigrade, which freezes at 0 degrees centigrade, right? Which has a density of 1 gram per milliliter, then what do you call that substance? It is a pure substance. That means that substance has its own unique properties. Okay? That's one thing. The other thing, if you noticed from chapter 1 again, or chapter 2, I don't recall which chapter, pure substances can be separated by a chemical process. They can be separated by a chemical process. Then we call them pure substances. You cannot break them down in a physical process. You recall that?
Yeah.
Okay. We can break it down. We can break it down in a physical process. So water cannot be broken down by using magnets or by using filtration. Okay? But water can be broken down by using chemical process like electricity. You can pass electric current through it. So you can have hydrogen and oxygen on one time. Okay? So if a substance has its own distinct properties, and if it can't be broken down by a chemical means or a chemical process, it is called a pure substance. That is actually a difference between a pure substance and a mixture. If I ask you, maybe your son someday will ask you, Mommy, I need to know what's the difference between a mixture and a compound on the school assignments, maybe. Okay? How do you answer that?
Pure substance can't be broken down physically, but a mixture is broken down. Or is, I don't know how to say it.
A mixture, yes. Yeah, go ahead.
Okay, pure substance cannot be broken down physically. Is that what it
Yes. A pure substance cannot be broken down by physical process, by physical means, yes. But mixture can be broken down by physical means. You know, any physical way. Using magnet, using filtration, using tearing, or using isolating, or using colors, just by identifying with the colors. They don't need any chemical reactivity generally. You don't need any chemical process. You can just break them down by using your own technique, your own way. Okay? So that's the difference. And also we have, that's the difference between a mixture and a pure substance, okay? And a pure substance, again, pure substance have been divided into what? into elements and compounds. Very good. Pure substances. Compound is a pure substance. Element is also a pure substance. Remember, because they have their own identities, their own properties, their own characteristics. And also, a pure substance, which is a compound, can be broken down by chemical means. Okay? Whereas an element, like sodium, potassium, even though it is a pure substance, it cannot be broken further by any means, either physical or chemical means. Okay? So that is actually the difference, the main difference that you have to explain to your daughter, to your sons, or to yourself, that mixtures can be separated by physical means. Compounds cannot be separated by physical means. That's the difference. Okay? And mixtures also have heterogeneous mixture and homogeneous mixtures, right? Which means heterogeneous mixtures, they don't have uniform composition throughout the sample, and a homogeneous mixture has a uniform composition throughout the sample. Can you give me an example of heterogeneous mixture, Argeta? Can you give me an example of heterogeneous mixture? Kathy. What is an example of heterogeneous mixture? I'm sorry? Yeah? Give me an example of mixture. Salt and water. Is salt and water a mixture?
Yeah.
Yes?
Yeah.
Okay, explain me why.
Salt and water.
Mm-hmm.
Because they can be separated by physical means.
How do we separate?
Evaporating dish.
Okay. So boiling.
Yeah.
By using the process of boiling. Boiling is a physical technique, right?
Mm-hmm.
When you boil, the water will be evaporated, the salt remains, right?
What does it mean by uniform composition?
Yes, that's what I'm coming to that point. So now, it is a mixture, but what kind of mixture is that? It is, does salt and water has a uniform composition throughout the sample, or it doesn't have a uniform composition? A uniform composition means when you look at it, it looks like it's the same. There is no layer.
Yeah. It has a uniform composition.
It has a uniform composition, right?
When you look at it, it's like water, like
It looks the same.
It looks the same. Salt and water looks the same. Like when it's mixed, the solution.
Yeah, but once you boil it, it doesn't look the same. It looks like it's solid. And
Yeah, that is true.
Yeah.
That's true. But
Well,
when
when
you look
it's
at it,
mixed.
So you're talking about when it's mixed.
when it's mixed, yeah.
Does it
When
look the
it was a
same?
mixture, yeah. After you separated it, it's not a mixture no more. It's a pure substance. You have salt on this side, you have water on this side. Does that make sense?
So it'd be the homogeneous mixture because
Yes.
it looks the same?
It looks the same. I can give you a heterogeneous mixture. You mix salt and pepper. Simply. You mix oil and water. You can see the layers, right? You can see the oil on the top, the water on the bottom, right? This doesn't look uniform. So is it heterogeneous or homogeneous mixture? Heterogeneous mixture. Do you understand the difference between homogeneous and heterogeneous?
So the two has to be from one.
Yes, they look like the same. They, like I may ask you a question. Air is example. Air is a homogeneous mixture. Look, air. There is air here. Believe it or not, there is air here. What are the components of air? Oxygen, nitrogen. There are some trace elements, right? All of them look the same. There is nitrogen here. There is oxygen. We can't differentiate that. Is it homogeneous mixture or heterogeneous mixture? It's homogeneous mixture. Does that make sense?
So the oil and the water is homogeneous.
The oil in the water? No, heterogeneous. Oil and water, salt and pepper.
All our water is a uniform composition.
No, you mix oil and water. What do you see on the top? You see the oil and you see the water. Doesn't you see uniform means that they look like the same. Like salt water or sugar water looks like water unless you tasted it. Don't
It's
taste it.
homogeneous. Is that what it says?
Homogeneous, yes. Homogeneous, yes. Does that make sense? Yes? Okay. Okay. So solution is a homogeneous mixture that contains small particles. There is also what we call it a colloid. Colloid is a homogeneous mixture with larger particles often have an opaque appearance. Sometimes you can see colloids. Colloids are something like suspensions, something like you can see solid parts. Okay. There are two parts in a solution. In a solution, you have solute. The solute means the substance that is present in fewer amount, in less amount, or the minority part. A solvent is a substance that is present in a larger amount. So basically, solution means that the result of solute plus solvent. Okay. Since we are dealing with water every time, because most of the time we are dealing with inorganic chemistry, not organic. So we think that water is a solvent medium. If water is a solvent, we call the solution that is formed from water aqueous solution. What is the abbreviation for aqueous? AQ, yes. AQ is the aqueous solution. Okay? We have a solution of gases like oxygen, carbon dioxide, and nitrogen. We have an aqueous solution of sodium chloride. This is a liquid solution, a gas solution, and solids even form a solution, like mercury dissolved in silver, a liquid in a solid. These are three different ways of, or three different types of solutions. Solution can be divided as something called electrolyte and non-electrolyte. Electrolytes and non-electrolytes. Okay, what is the difference between electrolytes and non-electrolytes? A substance that conducts an electric current in water is called electrolytes. And a substance that doesn't conduct an electric current in water is called a non-electrolyte. So, you take, for example, sodium chloride. What kind of compound is sodium chloride? Is it ionic compound or like covalent compound, or is it a molecule? Sodium chloride. Sodium chloride, Faith. What is sodium chloride? What kind of compound is that? Argenta, what is sodium chloride? Is it ionic or covalent?
Ionic.
It's ionic. It's ionic. How do we know it is ionic?
Metal and non-metal.
It is made from metals and non-metals. Anything made from metals and non-metal is ionic compound. Okay? Now, if this ionic compound, it has two different charges. Sodium chloride, when it dissolves in water, it decomposes into ions. What are the two ions that are present in sodium chloride? A sodium ion and a chloride ion, right? So, this is considered to be as an electrolyte. The reason why it is considered to be as an electrolyte because it can carry an electric charge. Because you have two different ions. For electricity to transfer from one end to the other end, you need to have two different charges, a positive end and a negative end. Ionic compounds have that capacity. Ionic compounds do that. So most ionic compounds that dissolve in water, we call them what? Electrolytes. Okay? For example, if you have a water, okay, but you dissolve, for example, hydrogen peroxide here, H2O2, or you dissolve sugar, C6H12O6. Sugar dissolves in water, true or not? You dissolve sugar in water, right? But what's the difference between dissolving sugar in water and the difference between dissolving sodium chloride in water? The difference is that when you dissolve sugar in water, no ions are formed. There is no dissociation of ions, just like hydrogen peroxide doesn't dissociate here. Sugar also doesn't dissociate. It is organic compound. It doesn't dissociate. It doesn't form an ion. Okay? If it doesn't form an ion, can it be electrolyte? It cannot be electrolyte. It can be non-electrolyte. Okay? Non-electrolyte. So, for a substance to be electrolyte or non-electrolyte, what is the criteria? The criteria is what?
For electrolyte, it should have the opposite charges.
Yes, it has to have two different charges or opposite charges. That is said to be electrolyte. It has to be dissociated and it has to have two different ions or charges. Dissolving by itself doesn't make the substance electrolyte. Please, this comes as a test in a true or false. Okay? If a substance dissolves in water, it is electrolyte. True or false, Argita? If a substance dissolves in water,
In water, you say it's called the electrolyte.
yes. If a substance dissolves in water, it's called electrolyte. True? Okay, how many of you say true? I have two people here. Okay. How many of you say false? How many of you say I don't care? Okay, if a substance dissolves in water, it is electrolyte. Or if a substance dissolves in water, it is not electrolyte. So the true statement is sugar dissolves in water, but it's not electrolyte. Kathy, it's not electrolyte. Sugar dissolves in water. Or hydrogen peroxide dissolves in water, but it's not electrolyte. So what?
So there shouldn't be a question on that unless it's gonna say
Okay.
all of the above.
Yeah, it should be false. If dissolves, okay, if a substance dissolves in water, doesn't necessarily be an electrolyte.
Okay.
Doesn't necessarily be
It
an
has to be
electrolyte.
ionic in order to have both negative and positive charge. That means they don't collapse with it. That means they don't dissolve it.
Yes, yes. It must be ionic compound. It must have ions in it. Okay? So you have to know the nature of the compound. Is sugar an ionic compound? It's not. Sugar is not ionic compound. What is ionic compound? Ionic compound is a compound made from ions, metals and non-metals. Sugar is C6H12O6. There is no metal there, right? It forms by sharing of electrons. So it's a molecule. Kat, you have a question?
Yeah.
Okay.
You said it must be ionic.
It must be ionic
Okay,
compound.
and so how would I know it's ionic again?
Okay, ionic compound always have metals and non-metals. Okay, ionic compound always have metals and non-metals. Okay, for example, if I say NaNO3, NaNO3, right? What is NaNO3? What is NaNO3?
Sodium nitrate.
Sodium nitrate, right? Is NaNO3 ionic or covalent compound? NaNO3. How do NaNO3 is composed? Where does it compose
It's
from?
metal and non-metal.
What is the metallic part? What is the non-metal part?
It's ionic.
Sodium.
Sodium's metal, and then nitrate is non-metal.
Yes. Okay? You have Na ion and NO3 ion. Na is a positively charged ion, NO3 minus is a negatively charged ion. Okay? So it is ionic. Okay? Whereas if I have SO2, what is SO2?
They're both non-metal.
Sulfur and oxygen, you see? Is it ionic compound? No, it cannot be because sulfur is a non-metal, whereas oxygen is also
Non-metal.
a non-metal. So it cannot be ionic compound, right? Do you understand the difference between how we can tell ionic versus covalent compounds? Does that make sense? So what do you call a substance that can carry electricity? Electrolyte. What do you call a substance that cannot carry electricity? Non-electrolyte. A substance that conducts electricity. Okay? What do you call it? Electrolyte. So which compound is you think, generally speaking, can be considered to be as electrolyte? For a substance to be electrolyte, what conditions must be fulfilled?
You must have ions.
It has to be first what?
Ionic.
It has to be first ionic. That's the first criteria. What is the second criteria? Well, it has to be ionic means it has two different charges anyway, right? What's the second
It
criteria?
has to dissolve in water.
It has to not,
It has to be dissolved in water. Again,
it don't dissolve in water.
wait. Now, there is another point here. You may have NaCl S. You may have NaCl AQ. What's the difference between these two?
That one's solid.
What is NaCl S?
Solid.
Sodium chloride, solid, right? What is NaCl AQ?
Sodium.
Aqueous, right? Which of the two is electrolyte?
The aqueous.
The aqueous. Does that make sense? Because this one dissolves in water. Sodium chloride dissolves in water. Just having sodium chloride, a solid sodium chloride, is not electrolyte, even though it is ionic compound. For a substance to be electrolyte, what is the criteria? Two criteria. What is the first criteria? It has to be ionic. That's the first one. So what's the second criteria? It has to be aqueous. It has to dissolve in water. It has to be aqueous. Does that make sense? So please, we understand that.
So for it to be electrolyte, it has to dissolve in water and it has to be ionic.
Yes. Yes. Okay. Okay. Now we're going to discuss about solubilities. Okay. What is solubility means that the amount of a solute that dissolves in a given amount of solvent. Okay. You have a solubility. Solubility means, first of all, solution. What is solution? Solution is solute plus solvent, right? The solute is the minority part, the smaller part. The solvent is the majority part, which is, in our case, is water. There is also a tendency or a measurement that we measure how much solutes can be dissolved in a solvent. That is called solubility. Okay? And the solubilities have their own numbers, basically. It is usually reported as grams of solid per 100 milliliter, grams per 100 milliliter. For example, I'm not sure, but I know, I'm not sure exactly the number. The solubility of sodium chloride in water is 35 grams per 100 milliliter of water. That means if you have 100 milliliter of water, 100 milliliter of water can dissolve about 35 grams of sodium chloride. Okay? Now, here is my question. Let's say I have 20 grams of sodium chloride in 100 milliliter of water. Is this going to be dissolved or not?
Yes.
Yes.
It is. It is, no question about it. Let's say I have 30 grams of sodium chloride in 100 milliliter of water. It will dissolve because the solubility standard is 35, right? Let's say I have 40 grams of sodium chloride. It will not dissolve. Now, what do you mean when you say it will not dissolve?
I think it will dissolve, but it won't be. Yeah.
Okay, how many grams will be dissolved? How many grams will not be dissolved?
5 grams won't be dissolved.
About 5 grams will be left over. 35 grams will be dissolved. Because the capacity the solubility of sodium chloride. Every substance have their own solubilities. I'm just picking sodium chloride because I know sodium chloride. I don't know the others. I mean, there is an index value for that, right? Now, this idea will take you to saturated and unsaturated solution. Okay? A saturated solution means it's a solution contains a maximum number of grams of solid that can dissolve. Maximum number. Okay? If you add any more than that, okay, any more than that, it will not be dissolved. Okay? It will not be dissolved. Unsaturated solution means a solution contains less than the maximum number of grams of solute that can dissolve. Okay? Like if the solubility of sodium chloride is, if the solubility of sodium chloride is 20 grams, right? It is unsaturated because the maximum capacity is 35. Okay? Now, if it is over than that, it's going to be saturated. It cannot hold the desired amount. It cannot hold the maximum amount. You know the word saturated and unsaturated, don't you?
Sorry,
Yes.
I have a question.
Yes.
If it's less than the amount, it's unsaturated. If
Yes.
it's the exact amount is saturated,
Yes.
what if it's like above the amount?
It is like a super saturated solution.
Super saturated.
Super saturated solution. Okay?
Is it in chemistry? Like,
Yes. It's in chemistry. Maybe here, I don't know. Maybe here. Supersaturated or oversaturated?
okay.
It's oversaturated, right? Some literature they use oversaturated, some literature they use supersaturated. Okay. Solubility can be summed up as like dissolves like. Okay? What does that mean? Like dissolves like. Most ionic and polar covalent compounds are soluble in water as a polar solvent. Okay? Ionic compounds are polar compounds. What does polar compounds mean? What are polar? What is polar and non-polar means?
Polar is it's sharing the same amount of electrons, and non-polar, wait, go that backwards.
Yeah.
Non-polar
Reverse.
share, yeah, non-polar is sharing electrons, the same amount of electrons, where polar is sharing not the same amount of electrons.
Not
Yes.
really.
Yes.
Okay, say it again.
Polar solvent contains unequal amount.
Wait,
Yeah,
wait. Unequal.
Yeah.
Unequal. Is that what you said?
That's, yeah, basically, but in different words.
Okay.
Not the same amount, that's what I said. instead of
Oh,
unequal.
okay. Okay, not the same amount. Okay. In that regard, you're right. Okay. A polar solute, a polar compound means it's a compound that doesn't have equal number of electrons. Okay? In other words, the number of electrons are unsymmetrical, or the distributions of electrons is unsymmetrical. On one end, you have too many electrons. On the other end, you have less electrons. What do you call that? Polar. It's a polarization. Polarity. Okay? Polarization or polarity is unequal distribution. Unequal distributions of electrons. From this end, you have too many electrons. From this end, you have less. Okay? Water is also a polar solvent. So, polar solutes will dissolve in a polar solvent. That is why we call the concept, we summed up by saying like dissolves like. Polar solvent, polar solute dissolves in a polar solvent. Non-polar solute, they dissolve in a non-polar solvent. Okay,
So you can't reverse it, like non-polar can't dissolve in polar then, right?
yes. Oil doesn't dissolve with water, for example. Okay? Oil is a non-polar, it's an organic compound. Water is a polar. Okay? So there is not like and like. So it is not dissolving here. Okay? That is the concept of like dissolves like means. Polar solute dissolves in a polar solvent, non-polar solute dissolves in a non-polar solvent. Okay? Okay. here, this is what I say, is non-polar compounds are soluble in a non-polar solvent. Mostly, these kinds of nature you can see in organic compounds. For example, octane is C8H18. It's an organic compound. It's saturated hydrocarbons. Have you studied about alkanes? We discussed about alkanes. Very good. What are alkanes? Just to refresh your memories.
The organic compound.
Yeah, but they are called the alkanes are the organic families, and they have something. They have one feature. Alkanes are said to be saturated hydrocarbons. And what else we know about alkanes? All the compounds of all the families of alkanes are ended with what? A-N-E. A-N-E. Alkane. We have three different families. What are they? Alkane, alkyne, and alkene. Right? Alkane, A-N-E. What's the next one? Alkene, E-N-E. And then we have alkyne. Yes. The alkene and the alkynes are unsaturated. Unsaturated means what? It is in respect to the number of hydrogen atoms, where they have fewer hydrogen atoms than the alkanes. These are saturated. So saturated means they have enough hydrogen atoms. The number of hydrogen atoms are excess. The alkanes.
Excess or just
The alkanes, I would say the alkanes, they hold the number of hydrogen atoms as they need. They don't need more than that. They hold enough amount of hydrogen atoms. That's what it means. Alkane. Okay? And all alkanes, like the common feature of all alkanes, they ended with A-N-E, like octane, for example. How do I know octane is the alkane family? A-N-E. Methane. Methane. You remember methane? It is the main component of natural gas in the lab, for example. CH4 is the alkane family. How do I know? It is A-N-E, ethane, butane, propane, octane, pentane, A-N-E, N-E, N-E. If you come up with E-N-E, it's going to be the alkene family. And instead of ethane, you say what? Ethene. You see, E-N-E. And instead of hexane or butane, you say butene. Hexane, you say hexene. Okay? You also have a formula for using the, sometimes it's very hard to remember how many carbon atoms are related with the hydrogen atom, right? So maybe you can use a formula. Each family group, they have their own formula. For example, the alkanes have a formula CnH2n plus 2. You remember this formula? CnH2n plus 2. This formula stands for what? For the alkane groups. So if you know this formula, really you don't have to memorize the number of carbon atoms and attach with how many hydrogen atoms are related with that. For example, if carbon is 7, how many hydrogen atoms needs to be attached with 7 carbon atoms?
16.
According to this formula here.
16.
16. CnH2n plus 2, right? So n refers to the number of carbon atoms. If I have 7, it's going to be C7, 2 times 7 plus 2. It's going to be C7H16. You see? If I have 9, carbon is 9. How many hydrogen atoms
20.
is attached with carbon? 20. What is the name of that compound?
What? 9?
Yes.
Not.
No name.
No name.
No name. Yes. Octane. What is octane? What is the formula for octane? Oct means octagon, 8. What is the formula for octane?
C8, H18.
Oh, this here? Okay. C8H18. It's octane. Okay? It's 18. But we have to apply the formula here. C8H2 times 8 plus 2. Okay? Okay? So, if you remember the formulas, then you don't have any problem to find What is the formula for alkene? Yes.
CN, HN, H2N.
CnH2n. That's for alkene. The difference between alkene, yes. ENE, Kathy, ENE. You see, you have ANE, you have ENE, you have YNE. The ANE groups are called alkane. The ENE group are called alkene. The YNE groups are called alkyne. These are the three families.
Why do you add 2 on the alkane and not on the alkene?
Well, that is how they are divided. The carbon can hold different number of hydrogen atoms. If it holds up to the maximum number of hydrogen atoms, it is categorized under alkane groups. And it is also said to be saturated. Saturated. Do you remember what saturated means? It holds enough amount, maximum amount. Well, carbon is a group 4 element. It shares electron. It can hold less hydrogen atom than required. How much less? It can hold 4. It can hold 2. If it holds 4, for example, it's going to be alkene. It said if it is hold less than the required amount, it is coming to alkyne. Okay, now, Kayla, now you have to understand that it's not just because we are counting the number of hydrogen atoms, but that is sharing of electron is a different option. There is always a different options for sharing of electrons. They can share with 4, they can share with 6, they can share with 8. When they share, they also have their different chemical and physical characteristics. They can be saturated if they hold the maximum amount of hydrogen. If they have a less amount of hydrogen, they can be unsaturated. The unsaturated and saturated is not just a word. Unsaturated and saturated is also have a big impact on the chemical and the physical nature of that compound. Okay? Saturated hydrocarbons, for example, they are not actively reacted because they don't need. They don't need because they are saturated, they already have it. Unsaturated, like alkenes and alkynes, they are very much active in terms of reaction because they still have much more space to react with. Okay? That really makes a difference in terms of the chemical and the physical properties of substance.
Sorry to interrupt. Alkanes don't react like
Violently than the alkanes.
so they're like the group 8 elements. They don't have group 4.
There is no group 8 here.
No, I'm not saying they are group 8. I'm like they are like the group 8.
The alkanes.
They really don't react.
They don't. Yes, they don't really react with other elements. The alkanes, because they hold the maximum number of hydrogen are there, but the alkenes and the alkynes still have room, still have space to react with. Okay. I think we discussed about exothermic and endothermic reaction last time in chapter 5, right? Who can remind me the definitions of endothermic and exothermic? Heat is endothermic is heat absorbers.
And exothermic.
Exothermic is heat is released. Yes, yes, yes. Okay. Yes. For most ionic and molecular solids, solubility generally increases as the temperature increases. This is also a factor. You know, you can increase the solubility of the substance when temperature increases by dissolving a solid in a solvent at high temperature and allowing it to cool slowly. You can create a supersaturated solution can be made. Okay. A supersaturated solution contains more than the predicted maximum amount of solute at a given temperature. Just like what I said earlier. Like, for example, the maximum amount of solubility in water per 100 milliliter of water is 35 grams of sodium chloride. Now, you may want to increase the solubility nature of sodium chloride. What do? You increase the temperature of water. You boil water. It is a simple experiment. You can boil water it holds. When you boil water, basically, what would happen?
The water would evaporate and the sodium would stay.
Well, yeah, when you boil water, the water will be
The bonds are
evaporated.
broken.
Yes, it means there is a lot of rooms for the solute to hold. The molecules are expanded, right? If something is boiled, the volume is changing. Something solid, liquid, gas, that is the nature of matter, right? Something boils, molecules are expanded. That means they get more spaces to hold, right? So the idea of supersaturated comes here. We call that 35 grams of sodium chloride is the solubility of sodium chloride. It cannot hold more than that. But I want to hold 38 or 39 grams. I create what? Supersaturated solution. How do I do that? By boiling the water. By boiling the water, I allow the water molecule to extrapolate, to expand, and to hold more
So you don't
molecules.
boil it enough to make it evaporate, just enough to.
Enough to hold the molecules,
Right,
yes,
okay.
yes. Not, not evaporate and remove the water. Okay? That creates the solubility. And also, what is the point here? The point is solubility generally increases when temperature increases. Solubility decreases when temperature decreases. See, you might have a question like this in a true false items. Now, there are 2 points I want you to focus. One is all electrolytes are soluble in water. Faith will say true or false. All electrolytes are soluble in water.
True.
True.
False.
You say
False.
there, you say in order to be that, they have to be soluble in water and they have to be ionic.
Yeah, true.
Okay,
According to that theory, makes it true.
okay, all substances soluble in waters are electrolytes.
False.
False.
Good, very good. All substances that are soluble in water are not electrolytes. Okay, we have a
But
good
the first
example.
question you asked,
Yeah.
going back to the first question, are all electrolytes soluble in water? Was that what you said?
Yes,
Mhm.
yes. All electrolytes are soluble in water.
That's true.
That's true, yes.
Yeah, we did it.
All electrolytes are soluble in water, yes. Okay. Yeah, here we have to discuss about, gases. Solubility of a gas in a liquid is proportional to what we call it the partial pressure of the gas above the liquid. Well, pressure really doesn't have that much effect on liquids and solids, but pressure has effect on gases, okay? It's a simple example that you have your Pepsi or your Coke or whatever you button, it is always be compressed under higher pressure, right? When you open it, what will happen? The gas will be removed, okay? Because it's compressed under certain pressure. So what is removing is carbon dioxide. It's a gas. So what we can conclude from here is that solubility of a gas, because you have a liquid, the liquid, and then the gas, is always be dissolved when you are applied pressure. Okay? That means the more pressure you have, the solubility is increasing. Solubility is increasing. That law is said to be Henry's law. I have closed can soda, for example, here. Higher carbon dioxide pressure, that means higher carbon dioxide solubility. That means the liquid part in the carbon dioxide is dissolved here. Open can of soda, if you open it up, it will lose lower carbon dioxide pressure and lower carbon dioxide solubility. Yes, yes.
Professor, in slide 11, this believe it
Here?
11. Yeah, it says in contrast, the solubility of the gas decreases with increasing temperature.
Temperature, yes.
Can you explain that?
Well, you can also think about this. Why you want to keep your soda in the refrigerator?
To make it cool.
To make it cool.
Yeah.
Okay. Okay. What's the difference between if you leave your soda outside the refrigerator and inside the refrigerator?
The temperature.
The temperature. So which one you feel more? Which one you feel more tasty? If I bring.
Depends how you like.
Oh, come on. You keep the soda. You keep all your sodas in the refrigerator. Common sense, right? Why we don't keep it in the refrigerator every time?
To make
When you increase the temperature, what's happening is that even though I don't open it, there is a pressure, but because of the temperature, the molecules of the gas are starting to skip from the liquid part. Okay? So increasing temperature, decreasing what? Decreasing the solubility. Decreasing the solubility. So putting inside the refrigerator means that you are decreasing the temperature, you keep the solubility of the gas versus with the liquid increased. Yeah, because in the soda you have two solutions. One is the liquid portion of it, the other is the carbon dioxide, right? So the carbon dioxide is the gas. So there are two ways that you can decrease the solubility of carbon dioxide with the liquid. One is by removing the pressure. You open up the pressure. If you open up the pressure, if you open up the can soda, then the carbon dioxide will be skipped because you have atmospheric pressure. You have a pressure greater than the atmospheric pressure. That's how you can hear the whatever voice when you open it up, right? When you also, even if you don't open, but when you leave it as a room temperature, just like here, a room temperature, for an hour or 2 hours, somehow the solubility of the gas will be decreased. They will be evaporated. And you don't feel it tasty because there's no solubility there. There's no solubility there. So that's what it means.
Since we're already there, so what makes it, when you put the soda outside, like, or in the freezer, makes it pop?
What do you mean? What makes it?
It bursts.
It bursts. So in this case, since we already, when you put it outside in the freeze, if it's in, and if you put it in the freezer, it then if it stay longer, it's
Oh.
bursts. So
What makes it? It bursts when you bring it out from the refrigerator.
when you leave it for longer.
When you leave it for a long time.
Yeah, in the freezer.
That's a good question. That's a good question. What do you think? I haven't never thought about that. But yeah, you're right. It might be cooled down for a long time.
I guess it's compacting like all the elements together to where it just couldn't.
Does the decrease in,
Fired.
Professor, does decrease in temperature increase the pressure?
Obviously, it makes it a lot.
Well, one thing that we have to think about this. What's pressure? What's the idea of pressure? Pressure is force over area. Okay? Now, I can give you my assumption, Sunny. I can give you my assumption. You accept it or not accept it, it's your,
Now,
it's your case.
since you already said I was
No,
going to
here is
compare
the
it with
thing.
the heat.
What I was thinking,
Okay.
maybe you can refer to the literature also. You keep the refrigerator, you keep the soda for a long time,
Yeah.
and then I think you're mentioning that the molecules are compacting together, right? The molecules are bringing together. They will be, the more cold it is, the more the molecules are what? They become dense. They compact with each other. In fact, they are changing to solid.
Yeah. it is.
Common sense.
But-
It turns into solid, right? Now, about the bursting, okay? Why is the explosion? The area here is going to be down. The area is reduced. Now, if the area is reduced, now pressure is force over area. Okay, think about the mathematical perspective that a ratio, numerator divided by denominator. If the denominator, which is the area, is less and less, what will happen to this value right here?
The pressure will be higher and higher.
Pressure will be high because the denominator part is very, very smaller. It makes sense that it can be bursted because you have high pressure. You open it up, okay? That might be the reason, but check on the Google, maybe it might be related with somehow, but this makes sense. I mean, that might be the reason why it creates that explosion. Okay. All right, let's see the next one here. You know, when you are dealing with solutions, we have to also measure concentrations. Different ways of measuring concentration. how do we measure concentration? Okay, percent concentration. First of all, concentration means a concentration of a solution tells you how much solute is dissolved in a given amount of solution, you know? So that's a concentration. I say, for example, 35 grams of sodium chloride in 100 milliliters of water. That is a weight volume concentration. There is the volume concentration, weight volume concentration. There is also a very common way of measuring concentration, molarity. You heard about that? Not yet? Okay. 3 years ago? 3 years ago is not long time. 4 years ago. Okay. All right. Okay. Now weight volume relation. A weight volume percent concentration, or weight per volume percent, is the number of grams of a solute dissolved in 100 milliliter solution. Okay? A good example, just like I mentioned here, solubility. It's a weight volume relationship. 35 grams of solute per 100 milliliter of water or a solution. Okay? That's called a weight volume. So if the solute is measured in terms of grams, it's called a weight volume. If the solute is measured in terms of volume, it's called volume. I think they may have that, volume. Okay? We can look here. For example, vinegar contains 5 grams of acetic acid in 100 milliliter solution. Okay? So the weight volume is going to be what? 5 grams of acetic acid per 100 milliliter solution, that's called 5%. That's called 5%. Okay? 5 grams of acetic acid. Volume, percent concentration. Now, in volume concentration, here is an example. If a bottle of rubbing alcohol contains 70 milliliters of 2-propanol in 100 milliliter solution, then the volume concentration is also again in percent. Don't forget this sign. This is a percentage value. It's always per 100 milliliter. Okay. The only difference between weight volume and volume is a matter of solute. It's not a matter of solution. It's not a matter of the solution. If the solute is measured in terms of grams, it's called a weight volume. If the solute is expressed in terms of volume, it's called volume. But both of them are expressed in per 100 grams. So this is a typical example here. You have a solution of 100 milliliter, a solute of 70 milliliter, okay, of rubbing alcohol. So it is volume, percent concentration is 70%. If this is 20 milliliter, it's going to be 20 over 100 times percent is always times 100. And instead of milliliter, if we have grams here, 70 grams, it's going to be weight volume. Weight volume, it's not volume. You're comparing weight to volume, you're comparing volume to volume. Okay?
So, I have a question. Is there a unit?
It's a percent.
So
Just 70%. If we have a unit, I'll come to that point. We have a unit when we're dealing with the other concentrations. I'm pretty much sure they have molarity here too. Okay, well, let me just explain a little bit about ppm. ppm, have you heard about ppm? Okay, when a solution contains a very small concentration of solute, a very smaller amount of concentration of solute, it is said to be ppm. It is parts per million. It is parts per million. A mass of solute divided by mass of solution times 10 to the power of 6. Mostly, ppm is used for something related with the environment. Okay, they are going to be explained about what is the amount of heavy metals, the amount of arsen in drinking water. Okay, it's like 0.5 ppm. So that means 0.5 grams per 10 to the power of 6 grams of a solution. 10 to the power of 6 is 1 million grams. Okay, so this is one way of measuring a solution. Sometimes there is also ppb. ppb is parts per billion. Billion is 10 to the power of 9, okay? 1 ppm means 1 gram of a solute per 10 to the power of 6 grams of a solution. 10 to the power of 6 means 1 million. 1 ppb means parts per billion. 1 ppb means 1 gram of a solute per 10 to the power of 9 grams of a solution. 10 to the power of 9 grams of a solution. Okay, this is for a huge amount. You want to measure like the concentration of some metals in a big reservoir or in Chesapeake Bay or something like that. They are measuring in ppb, in ppm and in ppb. Parts per million and parts per billion. Billion and billion. Yes, here. Okay. Molarity is a very common way which you need to know because this is some of the concept of molarity is also being covered in the lab class. Molarity means is the number of moles of a solute per liter of solution. That's called molarity, and it's abbreviated by big M. Unfortunately, please don't get confused with that. A big M refers to molarity. Don't use a small m. That's a unit. That's a formula for M. What is molarity? It's moles of a solute divided by the volume has to be liter of solution. It's a liter of solution. The volume has to be liter of solution. Okay? That's how we define molarity. I'm pretty much sure we'll have some examples of molarity here. Yes. Let's see. Calculate the molarity of a solution made from 20 grams of sodium hydroxide in 250 million of solution. Okay? The very first thing is that we need to do is, as strategic analysis, what we need to do is we have to isolate what are the given amounts we have. Okay, we have 20 grams of sodium hydroxide. We have 250 milliliters of solution. Okay. And this is our given quantities, our known values here. This is our desired quantities, which is what we're looking for. Molarity. By the way, molarity, you can say M, big M, or mole per liter. Either way. You can say mole per liter, or you can say big M. So, what do you think would be the first thing we need to do here? Convert milliliter into liter, because the definitions of molarity is mole per liter. So any milliliter has to be changed into liters. How do we change milliliter into liter? How do we change that? By dividing?
By 1,000.
1,000. Or yeah, by dividing 1,000 or moving the decimal point to the left. Okay, 3 zeros. Okay. You divide a number by 1,000, you're going to move the decimal point 3 zeros. So, which one is the volume?
The 250.
250 milliliter of solution is your volume. Okay, so this has to be changed into liter. Okay, that's one criteria. What's the other criteria? Yes.
Convert grams to moles.
Convert grams to moles. Very good. So 23 plus 60 plus 1 gives you what?
40.
40. Yes. Can I have a witness?
Yeah, 40.
How many of you say 40?
40.
Yes, it should be 40. Yes. So, okay, we got 40. Then what do we do? What's the next step then? How do we change 20 grams into moles? How do we change 20 grams into moles? I'm sorry? Okay, show it so I can give you the answer. 20 grams, change 20 grams of NaOH into moles of NaOH. 20 grams of NaOH into moles of NaOH.
That's 200.
Take your time, Faith, take your time. Use the calculator.
23 over, so it's 23 times 20.
20.
800. So
That's too much, yes.
Should
According
be
to me.
460?
I'm sorry?
460?
20 grams of sodium hydroxide into moles of sodium hydroxide?
Isn't that like give you the
0.5.
Yes.
0.5.
What's your name?
Hannah?
Hannah. Hannah says 0.5, which I absolutely agree with her. 20 grams of sodium hydroxide divided by 40 grams of sodium hydroxide gives you 0.5 moles of sodium hydroxide. Are we okay with that?
No.
Okay. Can you explain how we get 0.5 moles, Anna?
I didn't do the crisscross thing.
It doesn't matter. Tell us how you get it.
I put 20 grams NaOH divided by 40 grams NaOH.
Okay. So that gives you 0.5 because you're changing the moles of sodium hydroxide. The moles, 1 mole of sodium hydroxide is how many grams? You told me that. 1 mole of sodium hydroxide is 40 grams, right? Do we agree with that? How many of you agree 1 mole of sodium hydroxide is 40 grams?
Oh, yeah, I agree with you.
No?
Okay, last lesson.
One mole
1 mole equals
of NaOH equals to what?
40.
40 grams. How do we get 40?
Yeah, the
Sodium is 23, oxygen is 16, hydrogen is 1. We add them up together, we came up with 40, right?
Yeah.
So if you have 20 grams,
20 grams.
it's going to be how many moles? Okay?
0.5.
20 grams over 40 grams times 1 mole of NaOH. That gives us 0.5 mole,
That's it.
right? 0.5 mole.
Yeah. Thank you.
You're welcome. Now, we still have to finish this. We have 250 milliliters of a solution, right? What do we do with that? Change into liters. So how do you, if you change into liters, what do you do?
0.25.
Oh, I'm sorry?
Will come 0.25 liters.
Yes, you have to divide this by 1,000. Okay? Milliliter has to be divided into 1,000 to change into liter. So you say 0.25 something? 0.25? Okay. So you put 0.25.
1/4 or 0.25.
250 divided by 1,000. 250 divided by 1,000. So, okay. So 0.5 divided by 0.25 gives you what? What's the number you get? Kathy, what you get? 0.5 divided by 0.25. Use your calculator. Give me the answer.
2.
2 even?
Yeah.
What's the unit weight?
Moles per liter.
Moles per liter, okay?
Or big
For
M. Big M.
big M. 2M. 2M. 2 mole per liter or 2M.
Why 2M?
M is a symbol for molarity, big M.
No, you say 2M. Let's say we use 1M. Why we say? Oh, 2, the number 2.
The number 2. The number 2M. Big M, right? Okay. Here is how we convert the molar mass of 20 grams of sodium hydroxide into mole. Okay? And here is how we convert to 250 milliliter solution into liter of solution by dividing it by 1,000. And finally, when we calculate here, we came up with 2.0 M. Big M or mole per liter, it's the same.
Does, it has to be, is there a rounding rule, like one does not weight? Or if I write 2, is it the same thing as 2.0?
Well, actually, this one has 2 significant figures here, babe. The reason why this one has 2 significant figures, I think this is more appropriate to write 2.0. If you ask me why, because the number of significant figures you have here, you have the fewest number of significant figures, 0.25, which is 2 significant figures. Okay? You know, we can also play, you know, once we know the formula for, you should remember what is the formula for molarity. Molarity means,
Moles per liter.
yes, molarity means always N over V. N over V, that's how I remember, N over V. What is N stands for? It's the number of moles of a solute. What is V stands for?
Volume.
Volume of the solution. And the volume is always has to be what? In terms of liter. N has to be in terms of what? In terms of mole. So if you know molarity is N over V, so you can play around. You may calculate just like density equals mass over volume. What is mass? If density equals mass over volume, then the mass will be what?
Density.
Density times volume. What is volume? Mass over density. You can manipulate the same way about molarity. If molarity is N over V, what is N? What is N? How do we calculate N? It's the number of moles.
M times V.
M times V. Yes, M times V. What is V? If I want to calculate V, volume. M over N. You see? So in order to deduce this, in order to really derive the number of moles or the volume, what we need to do is we basically know the basic formula, molarity, which is N over V. Then N equals to M times V. Then V equals to M over N. Just like density is mass over volume.
I thought it was N over N. It's M over N?
N equals to
No, V.
M times V.
Right.
And V equals to N over N, sorry.
Okay.
V equals to N over N, yes. Okay, so if you know this, you can tell this, you can tell this. Just like if you know density, mass over volume, you can calculate M, you can calculate V. Okay? Okay, so here is a question. Let's do this as a classwork. What volume in milliliters? I want you to calculate this as a classwork. Okay? Let's see how you can understand this. I want you to solve this problem. What volume in milliliters of a 0.30 molar of solution glucose contains 0.025 moles of glucose? Let's calculate this and give me the answer. Okay? This one, and I'm going to give you another problem. Can you write this? What is the molarity of 25 grams of sodium nitrate? I'm not going to tell you the formula of sodium nitrate. You have to find out what is sodium nitrate. What is the formula? What is the molarity of 25 grams of sodium nitrate? Right? Dissolve in 350 milliliters of solution. Okay, I'll repeat that. What is the molarity of how many grams did I say?
0.083.
Okay, if you get 0.83, 0.84, you are pretty much close. Anybody got closest answer? Anna, what do you get?
0.86.
83, 84, 86. Okay, I still take it. Kathy? A little bit louder.
0.84.
84, okay. Yeah.
0.84.
84. 83. Okay. Anybody has a different answer? Or anybody would know how we solve the problem? Argeta, what do you get?
0.84.
Okay. So pretty much we understood how we solve the problem? Do we understood that? Okay. Yeah, 0.83, 0.84, depending on the weight of each individual element that you took might make a difference. But that is in that area. Okay. How about the second one?
I know one.
1. 0883. 0.83. For the second one?
The second one, which is this one, right?
This is this one, yeah.
Yeah, 0.83.
That's point,
0.083.
yeah, that's the one I said first, 0.083, but for the other one, the one we write it, I have, one.
The ones that I detected you, the ones that are sodium nitrate.
Okay, I want for that.
You what?
What?
1?
I don't know what it is.
.857 something or 0.86.
0.86. How comes the first and second answer are the same? Looks like they are very much closer.
No, the first answer, which is the one you dictated to us,
Yes.
is 0.84, but the second one is 0.083.
Yes.
Oh, 0.083.
Yes.
Yeah, that's
Okay.
like that.
Okay. So are we getting to that area?
Yes.
Now, can we do the detect one? Because I don't know where to.
Okay.
Maybe I can different formula.
Okay. Okay. The chemical formula was sodium nitrate, right? It was NaNO3.
Oh,
We also
okay,
have-
okay, okay. I got it.
Right?
I didn't put that in the formula.
Okay.
No.
We also have how many milliliters solution? 350, right?
Yeah.
Oh, which is equal to.
350, right?
Yeah.
Milliliter of solution. And what is the amount of sodium nitrate given?
25 grams.
25 grams of sodium nitrate. What is unknown is molarity. Okay? What's unknown is molarity. So maybe you can't see it. I can turn on the light. Can you see it?
No.
Okay, yeah, sure. Maybe let's see. Okay. So in this case, molarity is the number of moles of a solute divided by volume of solution, right? The number of moles of a solute, which is our solute is sodium nitrate, and it's 25 grams, right? So what do we do? How do we get the number of moles of a solute from 25 grams? 25 grams of sodium nitrate has to be divided by what? 85. Where do we get 85?
The molar mass of
The molar mass of what?
sodium nitrate.
Sodium nitrate. Very good. So if you divide 25 by 85, what do you get?
0.294.
0.294. That is mole. Okay, 0.294 mole divided by
0.35
0.35
liters.
liters. Is everybody with me?
Mm-hmm.
So if you divide 0.294 by 0.35 liter,
You get 0.84.
point
84.
like this,
Yes.
0.84.
Mhm.
So okay, either you can say M, big M, or you can also say 0.84 mole
No, I didn't round it.
per liter. Does that make sense? Anybody has any question? Ask question if you have any questions, please. Yes, yes.
I make a mistake when I do
Here?
the formula, sodium nitrate.
85 grams. Grams, that's the molar mass of sodium nitrate. Okay, that comes from NaNO3. That comes from sodium has 23 grams. N has 14 grams. Oxygen has 48 grams. Because 3 times 16. You see, these values will be given to you during the test time. Okay? So you have to add them up. 23 plus 14 plus 48. I believe it gives you 85. Okay?
Yeah, we got 0.86 because right away we rounded off 0.294 to 0.30.
Okay, that's fine. That's really, I mean, it's a very slight difference. Okay? That's really fine. You understand the concept, the basic concept, how we calculate the molarity. That's my point. Any question you have? Any other question? Okay. Okay.
But
Yes.
during an exam or a test, would there be like two answers, like 0.84 and 0.86? You know what I mean?
Yeah.
So would there be two answers?
Will they be that close together, like the answers?
The answer
Yeah, I mean,
Because then we'll have to choose like two different answers, right?
I wouldn't give you a choice like that.
Oh, okay.
Yeah, I wouldn't give you a choice very much closer to each other, honestly. Okay? Well, I have graded some of your paper and I have seen some questions very much closer
Very
to each
close,
other.
you did have it like that.
Yes,
Yeah,
yes.
exam, yeah.
Well, I give you a bonus point for that
Okay.
because they are very much closer. Some of you, I think that was potassium chloride, if I don't make a mistake. The molar mass.
He did have two close.
Yes, yes. When I calculated it, you see, sometimes I just grab the question from the test bank, but I didn't do it by myself. And when I sit down and do it, and I have seen that they have very close answers, so I give you a bonus point for that. And you know that. But see, my point is understanding the concept. Okay. So if you understand, it means that you are understanding the concept. If you came up with that answer, that's my view. Okay, let's. Okay, dilution. Okay, we have to move a little bit faster.
You're trying to finish the chapter and give us a lesson.
Okay, dilution. We have time, Sandy. It's 12 o'clock.
So
This class is over 12, sorry. Uh-huh.
I'll be the test next week.
Yes, ma'am.
Trying to do, you see?
Yes. Dilution. Dilution. Okay, let's discuss something. Is that okay if I make a light? Let's see, so turn off the light. It's fine? Okay, dilution means the addition of solvents to decrease the concentration of solute, right? The solution volume changes, but the amount of solute is constant. You have a concentrated solution. Let's say you have 10 molar, 10 m of sulfuric acid. And I would ask, Kayla, I need 5 molarity of sulfuric acid, from 10 molarity of sulfuric acid. What's that she has to do?
Increase the solvent.
Increase the solvent. In other words, she's diluting that, right? So the question is, how much solvent, how much water she's going to add? She's not like just like she wish 10 milliliter, 100 milliliter, 200 milliliter. Of course, she has to add some water. But how many milliliter of water are you going to add? We don't know. Yes, that is the process of dilution. That's how dilution is.
Well, you want to cut it in half, so you would just do equal parts.
Well, here is a formula that using for dilution process. You have M1 V1 M2 V2. What does the product? What's M? Molarity, right? Molarity times volume 1 refers to the number of moles of 1. This is number of moles. Remember, molarity means N over V. M times V is the number of moles, right? What is the common feature between concentrated solution and diluted? This is a concentrated solution, the initial solution, and this is a diluted solution, right? What do they have in common, these two? What is the common feature between concentrated and diluted?
They have the same amount of chemicals in there, just more water.
Yes, they have the same number of moles of a solute. The number of moles of a solute is not changing. But what is changing is the solvent. The solvent, because you are adding water. So N, which is the number of moles of a solute, is the same in concentrated in the initial solution and the final solution. That's why we came up to this relation. Moles of a solute of the initial solution, which is M1 V1, equals to moles of the solute of the diluted solution, which is M2 V2. Okay, this helps us to calculate how many milliliter of solvent do we add to the concentrated solution to dilute it. This relationship is going to help us to find out how many milliliter of solution, how many milliliter of solvent are we about to add to dilute it. M1 V1 equals M2 V2. Let me give you, if you just bear this formula, hold this formula for right now. I'm pretty much sure we have some example here. Yeah, here.
Excuse me, Professor.
Yes.
You said it hasn't changed, but why is it changed from 1 to 2?
What's your question?
The M1, the M1 V1 is now M2 V2.
Yes.
Because it gives you like two
You're talking about
different
here.
scenarios, basically.
Oh, so
It-
2 is the second.
The
It's
second
not saying
case,
it's
yes.
times, that
Yes.
it's,
Go ahead.
sorry.
Go ahead.
It's not that it's times by 2, it's just the second scenario versus the first scenario,
Oh,
it's all the same. And
Okay,
the
so it's
split.
no calculation, it's just.
Yeah, it's just same first scenario,
Yeah,
second
that's the
scenario.
first one, the second one.
Yes, but there is calculation actually. M1 V1 equals M2 V2. V1 is the volume of the concentrated solution. V2 is the volume of the diluted solution, right? So we want to calculate how much water we're going to add to the concentrated solution to make it diluted. So this relationship is helping to dilute solution.
Yeah, but M times V equals N.
N, yes.
N equals N all
Yes.
the time, so
N1
you
equals
don't
M2.
want to multiply MV by 2.
No.
Right, that's
No.
what she was asking.
No, the 2 is just a number here.
Yeah.
So I think you said it in a very good way. But if
Yeah,
this is
that's-
second scenario, this is first
Right.
scenario.
That's what she said.
Okay, this is a diluted solution, this is a concentrated solution,
Oh.
in my case. Okay, 2 scenarios, 2 pictures are here, okay? Okay, let's see. I have example here. We have how many milliliters of 4% weight volume of solution must be used to prepare 250 milliliters of 0.08 weight volume of solution. Okay. We have 2 concentration here, right? Initial value C1, V1, C2, V2, right?
Professor,
Yes.
sorry, why is this one C1 V1 and the other one is M1 V1?
It doesn't matter, really.
So I can do X1.
Wait, it doesn't matter. Concentration 1, concentration 2. Instead of, if you get confused with this one, you can say this M1 V1, M2 V2. The first one was actually molarity. It is referred to molarity, right? The second one is not molarity, it is weight-volume relationship.
Concentration.
Concentration. Molarity is one way of measuring concentration. Right? Molarity is one way of measuring concentration. Now, which one is, you have 2 scenarios. I'll let me put that word. You have 2 scenarios. One has a solution with 4% weight volume concentration. The other one is a solution with 0.08 weight volume concentration. Which one is diluted?
The
The 0.08 is less diluted, right? How? Now the question is, it is diluted to 250 milliliter, but how much of the concentrated solution is needed to add water to get into 250 milliliter? To add water to get into 250 milliliter. So again, dilution is always related with either M1, M2 equals M1, V1 equals M2, V2, or C1, V1 equals C2, V2. Okay? C1, V1 is the initial values, C2, V2 is the final values. So C1, which is concentrated one, is 4% weight volume. C2 is 0.080, right? V2, which goes with C2, is 250 milliliter. C1, we don't know.
No, the V1.
I mean, V1, we don't know. We don't know here, right? But we know this relationship here. If you know this relationship, what is V1? C2, V2 divided by
C1.
C1. So, let's see.
Professor, is
Yes.
that why we got 0.080?
No, the 0.080 is given to you.
Oh, those 2 is given to.
That is given to you, yes. Those 2, you have 2 different concentrations, 2 different scenarios. The first concentration has 4%, which is highly concentrated. The second one is 0.080, which is less diluted. And it is diluted up to 250 milliliter of solution. Now, to dilute that, you have to take the volume of the concentrated one, the initial one. You take that, and how much water does that? How much water are you going to add to get into 250 milliliters? You just can't take water simply and drop it, or and put it in the, you have to have a limited amount of the concentrated solution to get it to 250, right? So that's why we are going to calculate the volume of the desired quantity, the volume of the concentrated one, which is going to be what? It is going to be
250 times 0.080.
Yeah. It's going to be from this relation, we have C1 V1 equals C2 V2. We calculate V1, which is C2 V2 over C1. We know C2 is 0.080, V2 is 250. This is 4 percent, and percent will be eliminated by the observers, right? And we calculate 5 milliliter of the solution, the dopamine solution, right? To make it into 250, how many milliliter of water should I add?
250 minus 5.
Yes? 200?
Yeah.
To make, because we want to dilute into 250, right? We take the concentrated solution 5 milliliter. And in 5 milliliter, once we have that, to make it 250, how many milliliter of water we have to add?
245.
245. To make it 250, because the final is 250 milliliter. You want to dilute up to 250 milliliter solution. Okay, so this helps you 5 milliliter is from the concentrated. You take 5 milliliter here in this container, and then you take pure solvent water, and you add 245. Why? To make it 250 milliliter. Because the diluted solution has 250 milliliter of concentration.
Okay, so the final answer for that is like
5 milliliter, yes. Yes. But when you are doing this in the laboratory, when you are doing this real experiment, to make it 250, you must have what? On one side, 245 milliliter of water. Add into 5 milliliter of the concentrated solution to make it 250. There is, okay, this is the concentration. Now, osmosis. Osmosis means it's a membrane that surrounds living cell in a semi-permeable material. What is osmosis, by the way?
water.
Osmosis water?
The movement of water through a semi-permeable.
Okay, say it loud.
The movement of water through a semi-permeable.
Yeah, it's not water. It's a movement of water through a semi-permeable material. It is a passage of water and small across the same permeable member from a solution of low solute concentration to a higher solute concentration. Okay, if you want to have osmosis, you must have two different concentrations, and you must have a semi-permeable material. Now, the movement of a water from low solute concentration to a higher solute concentration. If you have semi-permeable material, and if you have the same concentration, then there is no osmosis. No more osmosis. Osmosis is always it's a passage, it's a flowing. Okay, that's how the definitions of osmosis is. Okay, I'm finishing. I'm about to finish. Don't leave. You can see. I mean, we have to. Yeah. Okay. Osmotic pressure is the pressure that prevents the flow of additional solvent in the solution on one side of a semi-permeable membrane. You can have a water, you can have solute, solute plus solvent here. You can have this is the idea of the osmosis here. Now, osmosis and biological membranes. Two solutions with the same osmotic pressure is called isotonic. Isotonic means that the situations that I already told you. That, you don't have low solute concentration, you don't have high solute concentration. The concentration of the solution is going to be the same. Like, we have a cell here, we have a concentration here. The concentration in and out are the same, so there is no flowing, okay? Let's say this is one kind of cell, I don't know. It might be red blood cells, for example. Okay? Red blood cells, anyway, they are semi-permeable material. So there is a solution You use intravenous solution, IV
We were
solution.
just saying, now you just got to nurse it.
Oh, okay, you tell me. So what is IV solution, Sandy? You are the professional
we
person.
were just saying, go ahead.
What is what is the idea of the IV solution? You give IV to
We give
people,
IV,
right?
but it comes in different concentration. Sometimes it's like with more concentrated with electrolytes.
Okay.
And sometimes if you dehydrate and your electrolytes are, they normal, you give, isotonic one.
Isotonic. Okay, what's isotonics? That's what we want to hear. That's important. That's isotonics. What's isotonic solution? Isotonic means that they have the same osmotic pressure, right?
Mm-hmm.
Now, people, they cannot be feed. You can't feed them. You give them the IV solutions. Why do we give them the IV solutions?
You have concentrated, so you want to make it even.
Yes. In other words, the concentration of the blood cell has to be the same as the concentration of solution. Because if it is more than the red blood cells, because the red blood cells is semi-permanent material, or if it is less, you're killing the patient. Okay? There are different situations. We're going to look at those situations. They are hemolysis and crenation, I guess. That's what they call it. Okay, let's say hypotonic solution. A hypotonic solution has a lower osmotic pressure than the body fluids. Okay? In other words, hypotonic means the concentration of the particles outside the cell is lower than the concentration of the particles inside the cell. What it means here, you can see that the water, this is higher here. Okay? What's happening is that water diffuses into the cell. No, this is a lower concentration. This is a lower concentration than the blood cell here. The solutions are starting to flow from the lower concentration to the blood cells. The blood cell, water diffuses into the cell, so the cell swells and eventually it's burst. Right? It's burst. So these kinds of situations, ruptures or swelling, is said to be hemolysis. Okay? And then we have also the reverse situation. Let's say that the concentration of the outside solution will be higher. So the liquids are starting to flow from red blood cells to the higher concentration. What happened to the blood cells? It's shrinking. It's getting shrinking, right? Yes. That crenation, I guess. What do you call that? The hemolysis is burst and swelling of the red blood cells. There is also hypertension. Hypertonic. Yeah, hypertonic solution. But this process is called crenation. The process is called crenation. Okay. Dialysis, I think you are familiar with that too. What is dialysis? Can you explain us what dialysis means? How is the blood is filtered through the kidney? That's called a dialysis process, right? If a person has a problem of dialysis, they have special kinds of instruments that is used. Can be substitute the kidney work, the kidney job, and that process said to be the hemodialysis is used, right? So I'm done here.